This is lesson 3 for day 2, which we're going to look at some different reasons, theorems, and postulates for proofs. So beyond the ones that we looked at for algebraic, so now we're going to move into kind of a lot of the vocab that we've already talked about so far. Complementary, we can use that as a reason with two angles adding up to 90. Supplementary, two angles adding up to 180. Adjacent, we don't use a ton, but since it is a definition, two angles that share kind of a common side or common vertex as well. A linear pair, adjacent angles that form a line or add up to 180 degrees. A right angle, measuring 90 degrees. A straight angle, measuring 180 degrees, and then a line bisector, dividing it into two congruent segments, or an angle bisector, dividing it into two congruent angles. So these are all going to be reasons. We also have some segment addition. Remember when we add the left and the right and we set it equal to the total? That's adding segments. Or if we add the left angle and the right angle and set it equal to the total angle, that would be the angle addition postulate, because we're just adding. And then we have vertical angles being congruent. We have already talked about our linear pair basically being supplementary. So postulate or definition we've talked about thus far. And then midpoint and bisecting we just had above as well. Again, two parts that are congruent to each other. And vertical, we've had our congruent. We don't use the definition as much because that's really just two angles that are being formed by the intersecting lines. We usually use kind of the theorem more so, but I'm not going to get too picky with things. But a lot of times we use kind of the theorem versus the definition with vertical. Otherwise, pretty much anything else, if they give you the word, you're going to be using the definition. So honestly, all of these examples here, we're going to be using definition of midpoint. What does it mean for something to be the midpoint? We know it's going to mean that this segment and this segment are equal or congruent. Either is fine. So equals my. So this one using bisector. So that is the definition of, and it's not segment, it's angle bisector. If you just put bisector, I would still count it correct. But if you want to be more specific, since it is angles that's being bisected. So this one, we want to state that this angle up here is congruent to this angle right here. So angle, and our A got kind of cut off there, angle ABD, this one right here, ABD, is congruent to angle DBC. So that left is congruent to that right. These are vertical, so we would use the vertical angles theorem to state that they are congruent. Next up, we have perpendicular. That's that symbol there, which forms a right angle. We could also just say definition of perpendicular, and that is going to mean that angle 1 is a right angle, because perpendicular forms right angles. Supplementary, so definition of supplementary is going to be our reason. And what does it mean to be supplementary? It means that the measure of angle 1 plus the measure of angle 2 has to total 180 together when we add those angles. Next up, make a conclusion about these angles. Well, together they form 90, and we know two angles that add up to 90. Definition of complementary. So that would mean that angle ABD, this one right here, and angle DBC are complementary. And you could add them and set them equal to 90, and that could also be the same reason. And then we have our AD bisecting angle BAC. And that is the definition of an angle bisector. when we show that those angles are congruent. So you could even go to say that angle BAD is congruent to angle DAC, definition of an angle bisector. If something is equal, the next step is usually that it's going to be congruent. So anytime we kind of see that equals, double check and make sure that you're not going to use the definition of congruence, because that is most of the time we're going to go from either equal to congruent or congruent to equal. Complementary, we said we're going to use the definition whenever we're given our word. Definition of complementary, which means that these two add to 90. So measure of angle 1 plus the measure of angle 5 equals 90. If something is a linear pair, then it is supplementary. Since we have two blanks, we'll go ahead and go to supplementary first with our linear pair postulate or definition. And that is angle 1 and angle 7 are supplementary. And then if something is supplementary, we can define that definition of supplementary and say that the measure of angle 1 plus the measure of angle 7 equals 180. So I'm okay a lot of times if it doesn't have that additional step that you just go from linear pair to 180. Because we do have under the words linear pair up there that it is forming that line in 180. So you can kind of go directly to that. All right, this one, we're going to go definition of right angle, because we've got our word right angle there. So we're going to say that the measure of angle 8 equals 90. Notice that I'm adding that m when I'm setting it equal to an actual number. Measure of angle 9 is equal to 90. And then we're going to go ahead and set measure of angle 8 equal to the measure of angle 9. And you could either use transitive, because they both equal 90, so they are equal. Or we could substitute in the measure of angle 9 in for the 90. So substitution or transitive property. If something's supplementary, we're going to use the definition of supplementary and state what does it mean to be supplementary. It means they add up to 180. Right angle, again, definition of a right angle. If you're kind of starting to see this trend, what is a right angle? It adds up to 90. So the measure of ABC is equal to 90 degrees. If it's equal, then it's congruent. And we use the symbols up above when we use our congruence, because we're talking about the picture, and that is definition of congruent. And you could put segments or just definition of congruence is fine too. Last one, we're going to go ahead and set them equal. So measure of ABC is equal to measure of JLM because they both equal 147. So again, substitution or transitive. Since they both equal 147, they are equal. That's the transitive property. And if something is equal, then it is congruent. So angle ABC, no measure, is congruent to angle JLM. Definition of congruent angles or just definition of congruence is fine as well. So we're going to practice a lot of these. It really just takes practice. So I will be sharing out a Quizlet, which is kind of like flashcards to assist you as well, but we will be working with these over and over and over, and luckily a lot of these you have already seen from our first two chapters. So the vocab is already kind of in your brain. It's just learning which one we're going to use and kind of how to use it. The more you practice, the easier it gets.